നമസ്കാരം എല്ലാവർക്കും ഗ്യാൻ അക്കാദമി മലയാളത്തിൻ്റെ ഒരു പുതിയ സെഷനിലേക്ക് സ്വാഗതം. ഇന്നത്തെ ക്ലാസ്സിൽ നമ്മൾ നോക്കാനായിട്ട് പോകുന്നത് Coulomb's law and its vector representation. Before I start, you have to take a pen and a paper to note the important points which I'm going to tell you. So, let's get started. First of all, what is point charges? Point charge is extremely small in size as compared to its separating distance, or we can say that it is having very small volume as compared to distance separating them. അപ്പോൾ അങ്ങനെയുള്ള ചാർജസിൻ്റെ വോള്യത്തിനെ നമ്മൾ നെഗ്ലക്റ്റ് ചെയ്യുന്നു. അപ്പോൾ അതിൻ്റെ വോള്യം അല്ലെങ്കിൽ അതിൻ്റെ സൈസ് നമ്മൾ കൺസിഡർ ചെയ്യില്ല, അതിനെ സെപ്പറേറ്റ് ചെയ്യുന്ന ഡിസ്റ്റൻസ് മാത്രമേ കൺസിഡർ ചെയ്യത്തുള്ളൂ. സോ അങ്ങനെയുള്ള ചാർജസിനെയാണ് പോയിൻറ്റ് ചാർജസ് എന്ന് പറയുക. നമ്മൾ ചാർജസിൻ്റെ പ്രോപ്പർട്ടീസ് പഠിക്കുമ്പോൾ തന്നെ പഠിച്ചതായിരുന്നു. ലൈക്ക് ചാർജസ് വിൽ റിപ്പൽ ആൻഡ് അൺലൈക്ക് ചാർജസ് വിൽ അട്രാക്ട്. അപ്പോൾ ഈ അട്രാക്ഷൻ അല്ലെങ്കിൽ റിപ്പൾഷൻ്റെ ഫോഴ്സിനെ ക്വാണ്ടിഫൈ ചെയ്യുന്നതാണ് Coulomb's law. So Coulomb's law states that the force of attraction or force of repulsion between two charges, consider here 2 point charges separated by a distance r or d, q1 and q2 separated by a distance r. So here the force of attraction or force of repulsion between the two charges is directly proportional to the product of two charges, that is q1 and q2, and inversely proportional to the square of distance between them. If you want to remove that proportionality constant, you have to add a constant, and the constant here is k or a. The value of k is purely depend on the medium. For convenience, we have taken the value of k as 1 by 4 pi epsilon, where epsilon is the absolute permittivity. F is equal to 1 by 4 pi epsilon naught q1 q2 by r square, where epsilon naught is the permittivity of free space and its value is equal to 8.854 into 10 to the power minus 12 Coulomb square per Newton meter square. If we are considering a dielectric medium, then the dielectric constant also taken into care. So epsilon r is the permittivity of the medium in which charges are placed related to the permittivity of free space, and it is called as the relative permittivity or dielectric constant, whose value is 1 for free space. Relative permittivity of a medium is defined as a ratio between permittivity of the medium to the permittivity of free space. As we all know, permittivity of free space is equal to 8.854 into 10 to the power minus 12 Coulomb square Newton meter square. So we are finding the relative permittivity with respect to permittivity of free space. This relative permittivity equation is really important, and epsilon r is equal to epsilon by epsilon naught, or permittivity of medium in terms of relative permittivity is equal to epsilon naught into epsilon r. Here the value of k depends upon the nature of medium and the unit in which charges are measured. SI constant la k ന്റെ വാല്യൂ എന്താണെന്ന് വെച്ചാൽ k is equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. ഇതാണ് Coulomb's constant ന്റെ വാല്യൂ. So k is the Coulomb's constant and its value equal to 9 into 10 to the power 9 Newton meter square per Coulomb square in free space. Now we can see how to represent Coulomb's law in vector form. Here is your vector representation of your Coulomb's law. If the force here is a vector quantity, it has both magnitude as well as direction. Q1, Q2 are charges, it's a scalar quantity. So only vector parameter here is radius vector. And if you want to find the force of charges, force on charge 1 due to 2, F12 is given by 1 by 4 pi epsilon naught into q1 q2 by r square into r21, where r21 is a unit vector pointing from the second charge to first charge. Similarly, F21, here the force of attraction or repulsion is calculated on the second charge due to the first charge, and it is given by 1 by 4 pi epsilon naught into q1 q2 by r square into r12. Here the radius vector, unit radius vector, is pointing from the first charge to the second charge. Note one important point, that is r12, radius vector pointing from the first charge to second charge, is equal to radius vector pointing from the second charge to first charge, and the only difference is its polarity is different. It is equal in magnitude but opposite in direction, and hence the forces between them. So F12 is equal to minus F21. So far we have considered only 2 point charges. In case of more than 2 point charges, we have to apply superposition principle, and it states that if a number of charges are interacting, the total force on a charge is the vector sum of individual forces exerted on it by all other charges. If F1, F2, F3 up to Fn are the forces acting on a charge Q due to the charges Q1, Q2, Q3 up to Qn, then the net force acting on Q due to all charges is the vector sum of all these forces. So F is equal to F1 plus F2 plus F3 up to Fn. I'm going to give you 2 questions, 2 exercise questions based on the Coulomb's law. You have to work it out and comment the answer below. If you find any difficulty to answering that question, please mention that also. I'll help you out. Here is your first question. What is the force between 2 small charged spheres having charges of 2 into 10 to the power minus 7 Coulomb and 2 into 10 to the power minus 7 Coulomb, both are equal in magnitude, placed 30 centimeter apart in air? Second question. Suppose you have 2 small objects separated by a distance of 1 centimeter. Each object has a diameter of 10 to the power minus 3 centimeter. One object has an excess of 3 into 10 to the power 10 electrons, and other has an excess of 2 into 10 to the power 10 electrons on it. What is the electrostatic force that exert on each other? These are some important points related to your Coulomb's law. We've learned the charge quantization, right? Q is equal to NE, where Q is the charge, N is the number of electrons, and E is the electronic charge. Same law we are applying here and finding what is the value of 1 Coulomb. 1 Coulomb is equal to charge on 6.2 into 10 to the power 18 electrons. Second point, it holds only for point charges in free space. Third point, the direction of force is always along the line joining 2 point charges Q1 and Q2, which means the force is always along the line joining the 2 charges, and this force is called as a central force. I hope all of you have enjoyed today's session. If you like the session, please give me a thumbs up. Alright, അടുത്ത ക്ലാസ്സിൽ ഞാൻ പുതിയൊരു വീഡിയോ ആയിട്ട് വീണ്ടും നിങ്ങളുടെ മുമ്പിൽ വരുന്നതായിരിക്കും. അതുവരെയ്ക്കും ബൈ ബൈ.